So when we deal with factoring, we have a method called guess and check, where we can find two things that multiply to give us this value and add up to give us this value. The problem becomes when we have a value in front of our x squared term. We then have to find values that are going to multiply across when we start distributing and then add up to give us this, which can become a little difficult. So we have another method that eliminates all of the guessing called the middle out or AC method. And the way that this works is we are going to take the two outer values and multiply them together. In this case, 2 times -3, which gives us -6. And with this, we are then going to pay attention to the sign of the last term. If it's negative, we are going to subtract all of the pairs of multiples that combine together to give us -6. If it's positive, we are going to add them all together, and they will all contain this sign. Again, negative, subtract, positive, add with this sign. So in this case, because it's negative, we're going to be subtracting those pairs of multiples. So we're going to list every combination that can multiply to give us 6. We have 1 and 6, 2 and 3, and it helps to do this in order. So we'll continue with 3 and 2, and then back to 6 and 1. This prevents us from missing any along the way. And again, because this last number was negative, we will be subtracting. Subtracting each of these pairs of numbers, we get 1 minus 6 is -5, 2 minus 3 is -1, 3 minus 2 is +1, and 6 minus 1 is 5. The goal with this is to get the middle number, the coefficient attached to the x. Which of these pairs gives us that number? It's this last pair here. 6 minus 1 results in a 5. This is the a term that is multiplied to the x squared, and this is the c term, that's the constant. That's why it's referred to as the AC method, and it's referred to as the middle out method in some cases because we are going to take the middle out and replace it with these values. So we're going to replace this plus 5x with 6 minus 1. And the way we can do that is just attach an x to each of these values, because 6x minus 1x is 5x. So we're not changing the problem by substituting them in. If we were to simplify this back down by combining these like terms, we'd get right back to 5x. And now the goal here is to change this from factoring a trinomial to factor by grouping. If we group these into pairs, to group the last pair together, we'll put parentheses around them and put a plus in the middle, because whenever you do factor by grouping, you always want to be adding the two terms. And now with factor by grouping, all we have to do is find the common factor of each pair. 2x squared and 6x each have a common factor of 2x. So we can factor that out to get 2x times 2x squared divided by 2x leaves us with x, plus 6x divided by 2x leaves us with 3. Plus, we're going to do the same thing over here, and our goal is to factor out whatever it takes to get this exact term again. So notice we have -1x minus 3, and we need x plus 3. So what can we factor out? a -1. That would leave us with positive x and positive 3. And now that they're matching, we can just bring one of them down and multiply by what's added on the outside of each one. 2x here plus -1 or -1 here. So if we've done this method correctly, 2x minus 1 times x plus 3 should be the factorization of 2x squared plus 5x minus 3. Let's do a quick check. If we distribute this 2x, we'll get 2x times x is 2x squared. 2x times 3 is plus 6x. -1 times x is minus x. And -1 times 3 is minus 3, which gives us 2x squared plus 5x minus 3. This is exactly what we started out with, which means we have factored this properly. Now that example is a little simpler. Some of you may have been comfortable doing that with just guess and check. But what happens when we have a much more difficult example? The AC method or middle out method really starts to shine here. Again, we take our first and last values and multiply them together, which will give us this 84 or -84 if you choose to put the negative there. And because it's negative, again, that means we are going to subtract all of these combinations. These are all of the pairs of multiples that will give us 84. It may take a little bit of time to write them out, but it's a great idea to do it so that you don't make any mental math errors along the way. When we write all of these out and we begin subtracting each pair, we just need to find one pair that will subtract to give us that -17. And if you go through it, you will find that 4 minus 21 gives us that -17 that we need, which means we can take this middle out and replace it with 4x minus 21x. So let's go ahead and do that. We have 6x squared plus 4x minus 21x minus 14. And again, remember our goal is to pair these off and always leave addition in the middle of the pairs. Now we factor the common factor from each pair. 6x squared plus 4x, we have a common factor of 2 and x. So we factor out 2x to give us 2x times 6x squared divided by 2x will leave us with 3x plus 4x divided by 2x is 2 plus over here, remember, we want to factor out whatever it takes to get this exact term. So notice both terms are negative, so we want to factor out that negative for sure. And then also, each term has a factor of 7. So let's take that out as well and see if we can progress any further. We have -7 times -21x divided by -7 leaves us with 3x. And -14 divided by -7 is plus 2. Notice that's exactly what we needed in each of these parentheses to match up. So we can bring down one of them and multiply by what is added on the outside, 2x minus 7. And then, like always, it's a great idea to do a quick check at the end to make sure we did this correctly. 2x times 3x gives us 6x squared. 2x times 2 gives us plus 4x. Negative 7 times 3x is minus 21x. And negative 7 times 2 is minus 14, which leaves us with 6x squared minus 17x minus 14. And that's exactly what we started with. So we have properly factored this trinomial.